this is another 2023 number challenge. Here we look at the sum of this series here is 1 over I, but then the sign keep alternating. That is 1 minus half plus 1/3 minus 1/4 and so on and so forth. And we care about the first 2023 terms. And of course, we try to estimate the value up to 1,000th precision. That is the third decimal points. Yeah. So the background for this, of course, is regarding the alternating series. There is convergent test. That is, the series would converge if it satisfies the following two conditions. That is, the term itself is not decreasing, it's getting smaller and smaller, kind of getting bigger, and the limit as n goes to infinity, a sub n equal to 0. Now in our case, it does satisfy both conditions, right? So for alternating series here, because an is always actually 1 over n, it's getting smaller and smaller, and eventually it's go to 0 as n goes to infinity. So this series actually converges. In our case, is actually what is called alternating harmonic series. We know that if every sign is positive, the series sum would diverge and it value approximately natural log of n, right? But for the alternating harmonic series, it would converge and it converges to log 2, natural log 2. Okay, so for this, I don't cover the details, but you can check out the series expansion for log 1 plus x, or the integral from 1 to 2 of 1 over x, right? So anyway, so let's assume that's a given. Now what we need to do is to consider the partial sum. Okay, another important result regarding the partial sum of converging series is that the difference between the partial sum and the convergent value, in other words, the remainder terms of the sum, is bounded by the next term. Okay, of course, this a sub n here is all positive, right? So this value is bounded by this inequality here. Now, in our case, we would like to estimate the case of the alternating harmonic series and for the first 2023 terms, right? So let's just plug in the value here. What we get here is that the conversion value is log 2. So S sub 2023, the difference between log 2 is bounded by 1 over its next term, 2024. And 2024 is good, right? Because it's about 1 over 2000. That's definitely less than 0.0005, right? So this would give us a good bound for our estimate, right? So let's just use calculator to figure out the values here. Yeah. And of course, another thing is that the alternating series sum usually would be alternating greater than the conversion value, smaller, greater and smaller, and so on and so forth, and getting closer and closer to the conversion value. So in our case, we can get a stronger interval here, is log 2, greater than log 2, but smaller than log 2 plus its values, right? So when we use a calculator, we would get this, approximately the value here. So that means the log 2 plus 1 over 2024 does not change the third decimal point. The third decimal point is still like 6936. Yeah. So which means the estimate would be 693, 0.693. That is the answer to the original problem. Okay, I think this is an interesting problem. Hope you follow the steps, and please check out if you need to review some more background about the alternating converging series. Okay, so we also have many other, not many, but maybe a dozen or so 2023 number challenge problems. Please check them out. I have the video link from the description. And in the meantime, please like, share, and subscribe to the channel.